So counters. So what is a counter? Counter. So what is a counter? So counter is nothing but it will count the it will count the number of clock pulses. Okay. So counter is nothing but it will count the number of clock pulses. Okay. So number of clock pulses. So if you see like count the sequence of state upon the application of clock. When you apply the clock only, it will count the sequence. Okay. So counter can be, it can be up counter and down counter, and it can be up down counter also. Okay, it can be up down counter. Okay, up down counter suppose if you want to design n bit counter and n bit counter, it consists of n flip flop. It consists of n flip flops. Okay, so where you are using these counters in real life example or real time example means when you go to any shopping mall or any metro station or any shopping mall, so above means in the entrance there will be some rectangular entrance will be there, no? So you need to pass
Mhm.
that entrance. So
Yes,
that
sir,
means
sir.
yeah. So so what is the intention means they will sell some means tickets. Okay. So at last what they will do means they will they will check with how much means how many tickets are sold and how many with this count. Okay, they will match like that. Okay, and one more application is voting logic module. So you casted the vote, I think so. So when you are casted the vote, there will be like voting logic module will be there, no? So that means when you cast the vote, one slip will be generated. Okay, that slip you need to keep in the ballot box. So at the
Mm.
end of this polling, what they do means they will reset that they will make into that electronic voting machine to how many votes are casted. Suppose 1500 votes are casted, so they will count these slips. Okay, so both are matching means there is no mismatch in the voting like that. That is one example of a up counter. Okay, down counter means rocket launching machine. They will start from when they launch the rocket. They will start from the down count only. No, 10, 9, 8.
Nine, yes, yes, sir.
Yeah. Okay. These are the real time examples. Okay. So that means here so many real time examples are there. So mod of the counter. Mod in counter. So if it is a mod in counter, it will count from where to where means 0 to n minus 1. 0 to n minus 1. Okay. So how to find out this number of flip flops means this is the formula. So n is less than or equal to 2 power n. This is nothing but from this you can find out the number of flip flops. Suppose if I want to design a mod 7 counter. Okay. So how many flip flops are required? 7 is less than or equal to 2 power n. Okay. Suppose n if you keep 2, 7 is less than or equal to how much? 4. Is
Four.
this statement is correct or wrong?
No, wrong.
Wrong. So you need to keep n equal to 3. Then 7 is less than or equal to 2 cube means 8.
Eight.
This statement is right. So how many number of flip-flops are required? 3. Do you understood how to find out the number of flip-flops?
If it is mod six, the same it applies.
Same value. Suppose if you want to design mod 12 counter. Okay. So mod 12 means 12 is less than or equal to 2 power n. Okay. So n if you are taking as 3, 12 is less than or equal to how much? 8, no? The
Eight.
statement is
It is
wrong.
not.
Not wrong. So this is wrong, not correct.
Four.
So you need to take 4. So 12 is less than or equal to how much? 16. So minimum number of flip-flops are 4 flip-flops are
Four.
required. Okay. So mainly for designing the counter, you are using T flip-flop and JK flip-flop. That two operated in which mode means toggle mode. Toggle mode we already discussed, no? When J
Sir,
equal
can
to
you repeat that? T and JK flip.
we are Means for designing the counters, we use T flip-flop and JK flip-flop. The two operated in toggle mode. J equal to K
Toggle mode.
toggle mode. Toggle mode means when J equal to K equal to 1, what is the next state?
Toggle only.
Qn bar. No?
Q and bar.
And when T equal to 1, this is nothing but next state is Qn plus 1 is Qn bar toggle mode. Okay.
Yes, sir.
So depending on the type of flip-flop, okay, depending on the type of clock, okay, depending on type of clock, the counters are divided into two types. One is synchronous counter, okay, synchronous counter. Synchronous counter means what? Common clock will be given to all the flip-flops, okay, common clock will be given, okay. This is synchronous counter. And second one is asynchronous counter. Asynchronous means or we can call as ripple counter also. Ripple counter. So ripple counter means the output of one flip flop is acting as a clock for the next flip flop. We'll write here. The output of one flip flop will act as clock for next flip flop. Is it fine?
Yes, sir. Got it.
Okay. Yeah. Next. So I will design first. We'll discuss asynchronous counter or ripple counter also, asynchronous counter. So in asynchronous counter, uh, so there are some steps. Direct clock is given to the LSB of the flip flop. Direct clock is given to LSB of flip flop. Okay, and next flip flop receive the clock from the output of previous flip flop. As I told you, no. So that means output of one flip flop act as clock for the next flip flop. Okay, act as clock for next flip flop.
Log is given to LSB.
Next flip flop. Suppose if you want to design n bit counter, what is the mod of the counter? That means maximum how much it can count. Maximum mod of a counter is n equal to 2 power
And
n. Okay,
less than okay.
these are the possible states. Okay, these are the possible states, and count can be up count or it can be down count, up count or down count. Okay, so if you want to design by using T flip flop, it will be like this. So you have series of T flip flops. Okay, series of T flip flop. So this is let us take T naught, Q naught, and let us take a negage of clock, and this Q naught, okay, Q naught is acting as a clock for the next flip flop. Okay, and this is T1 and Q1. So T naught and T1, and similarly, let us take this is Q naught and this is Q1. Okay, up to so on. Okay, you are getting one more negage of clock to this flip flop, Okay, this is a let us take Tn minus 1 flip flop. Okay,
Hmm.
T flip flop. So these all are connected to toggle state, and these are the outputs of the flip flop.
Hmm.
These are the outputs of the flip flop. Okay, this is T flip flop, and this is also T flip flop. So here this leftmost flip flop is nothing but LSB of the flip flop, and rightmost flip flop is nothing but MSB of the flip flop. So as per the statement, direct clock is given to LSB of the flip flop. The output of one flip flop is acting as a clock for the next flip flop. Is it fine?
The output. Yes, sir.
This output is acting as a clock for the next flip flop.
Okay.
Okay, next. Design process we'll see. Design process of asynchronous counter. Design process of asynchronous counter. First, step 1, select the type and number of flip-flops. Select the type and number of flip-flops. Number of flip-flops. How to find the number of flip-flops? I told you the formula, no? N is less than or equal to 2 per N.
Super.
Okay. Step 2. Step 2. All the flip-flops are in which state? All the flip-flops are in toggle mode. If it is a JK flip-flop or T flip-flop, those should be
Toggle.
operated in the toggle mode. Okay. Step 3, direct clock is applied to LSB of the flip-flop. Direct clock, direct clock is applied to LSB of flip-flop only. LSB of flip-flop only. And first flip-flop applied as a clock to the second flip-flop. First flip-flop output. First flip-flop output act as a clock for the second flip-flop. Is it fine? This design steps. Okay. Shall I move forward? Okay. Yeah.
Yes, sir. Understood. Yeah.
Okay. Yeah. So I want to design asynchronous up counter, that to 3-bit up counter, that to 3-bit. Okay. I need to design. Okay. So what is the first step?
Have to check like
We need to
number
check
of flip flops.
number
Select
of
the
flip
type.
flops and type of flip flop. I'm using a T flip flop. I'm using T flip flop. How many number of flip flops are there? If it is n-bit counter, n flip flops are there. So that means a
Flip
3-bit
flops.
counters means how many flip flops are required?
Three flip
Three
flops.
flip flops. Okay. Again, next what I need to do? So all the T flip flops will be in which mode?
Toggle mode.
Toggle mode. Okay. So this is one flip flop and this is another flip flop. Second flip flop and third flip flop. So here T naught, Q naught, T1, Q1, T2, Q2. Okay. So these T1, T, T1, T2 is connected to which mode? Toggle mode. Toggle mode. And LSB of the flip-flop. This is LSB of the flip-flop. LSB of the flip-flop means direct clock is applied to LSB of the flip-flop,
Let's be of the flip.
and this is acting as a clock for next flip-flop,
Next flip flop.
and this also acting as a clock for next flip-flop. I'm using what pass negate of clock, negate of clock.
Package of
Okay,
bubble. Hmm.
bubble. Yeah. Okay. So these outputs these outputs are nothing but counter outputs. Counter outputs. Okay, counter outputs. Okay. So here first what I will do means first here I'm writing next slide. Yeah, here I will write uh, so clock and Q2. Q2 is nothing but MSB of the flip flop. No?
Hmm.
Q1 and
Le-
Q0,
Q0.
LSB of the flip flop. Okay. Suppose when clock equal to 0 initially, the outputs of all the flip flops are what? 0 only, no?
Zero. Zero.
0. Okay,
Hmm.
0. Okay, and next, when you apply first clock, first clock, always this will toggle, no?
Hmm.
This will toggle means this becomes 1, and this is negate. Negate means what? The
Becomes 0 next one. Hmm.
uh, negate means it is going from 0 to 1. This is passage or negate?
0 to 1. So you're giving negate, right?
Here clock is negate, but it is changing from where to where? 0 to 1. So
0
I
to
am
1.
asking this 0 to 1 is passage or negate?
Negate. Sorry, passage.
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 It's passage. Passage means what? This flip flop will not active. This will be toggled when there is a negate.
Negate.
Okay. So it will be in the previous state only. What is the previous state? 0.
0.
Okay. There is no transition in the clock. So what happens? It will be previous state only.
Hmm.
Okay. At first clock pulse, what happens? Q2 becomes Q2 is 0 and Q1 is 0 and Q 0 is 1. Is this fine?
So this one we have given at input, right?
It will toggle, no?
Clock, okay.
Every time, every time this will toggle. Why? Because direct clock we are giving, no?
Okay,
Direct clock. That means the direct to negate of clock you are giving to this first flip flop.
okay.
Okay.
Hmm.
So the outputs, whatever the outputs are there, output of this second flip flop and third flip flop, it depends on the output of this flip flop.
Output of it, yes, sir.
Okay. Next, at second clock, what happens? Again, this will toggle to
0.
0. So 1 to 0. This is negate or passage?
Edge.
Negate. So negate
So
means what? This will toggle.
other two will be toggle.
This
Yeah.
will toggle. This will toggle. This
That's
will
yeah.
toggle. 0 1.
Is positive edge.
Positive edge.
Positive.
Positive edge means what? This will be in the previous state only.
0. Hmm.
Okay. So this is what? 0 1 0. Is it fine? You understood?
Yes, sir. Got it.
Okay. At third clock pulse, what happens? Again, this will toggle 0 1. 0 1 means what?
Positive.
Passage.
So it will be 0 again.
It will be previous state. What is the previous state value? 1, no?
1. Hmm.
There is no transition. Transition means that this
Okay.
is not active. This will be previous state only. So this is 0 1 1. Okay. At fourth clock pulse, what happens? Tell me. It will toggle
It
from
becomes 0 again.
1 to
0. So
0.
1 to 0 it is negate.
Mm,
It will toggle again 0.
0
Then it doesn't 1 to 0 it is negate. So
mm,
it will toggle again 1.
1. So this is 1 0 0. Okay. At fifth clock pulse, what happens? Tell me.
Then it goes to 1.
0 to 1.
So it doesn't change anything. So it 0.
Yeah,
So it remains again 1.
1. So this is 1 0 1.
0.
Sixth clock pulse.
0.
Mm,
So it goes to negate. So it will be 1 again toggle.
mm,
So 0 1 passage. So it remains same 1.
1
1 1 0.
1 1 0. Seventh clock pulse.
It goes again to 1.
Mm,
So 0 to 1 passage. It remains same.
mm.
1 1 doesn't affect. So it remains same 1.
So all are ones. Okay. At eighth clock pulse, tell me. It will change to 0, 1 to 0, and again it will change to this is negative or positive. Hello.
Sorry, sir. I was on mute. It again to 0.
0 again
Again it will 0.
0. So all are zeros. So this is nothing but mod 8 counter, up counter. Okay.
Sir, why it is called as up counter?
Why? Because first see here. First 0 clock pulse, it is start from 0. Next it is coming to what? 0, 0, 1.
1.
That is 1, no? Again
Okay.
2,
Again 2,
3, 4,
3,
5,
4,
6,
5,
7, 8. After 8, it is coming to the initial state.
0. Okay.
Okay. So how many
Okay.
states, how many counts it is counting means mod 8 counting means from 0 to 7 it is counting. Is it fine?
0 to 7.
Okay.
Like,
Yeah.
hello.
Yeah, yeah. 0 to 7. Shall I move forward?
Yes, sir. 0 to 7. Yes, sir.
Okay. So here, suppose if you want to draw the timing diagram, first I am drawing the clock. Okay. So I'm drawing the clock. This is 0, 1, next 2, 3, 4, 5, 6, 7. Let us take 8. Okay. Yeah, till 8 you take. This is clock. Okay. So clock is passage or gauge.
Our clock is negate, sir.
Clock is negate. Yeah. Clock is negate. Okay. So let us take this is a negate. Negate. Okay. This is a negate. This is negate. Okay. So always let us take this is negate. So always Q naught will toggle, no?
Always Q not will toggle.
LSB of the flip-flop will toggle, no? So that means during this negate, initially this is 0 if you consider. So this will toggle. This will be 1 till next negate. Again, this becomes 0 and till next negate. Again, this becomes 1 till next negate. And this becomes 0 till next negate. Again, this becomes 1 next negate. And this becomes 0 till next negate. Okay. So this is a Q naught. Okay. So this is a 1, 0, 1, 0, 1, 0, 1. Okay. Next, what happens? This Q naught is acting as a clock for the next flip flop. No,
Sir,
Q naught is acting as a clock for the next
the
flip
next
flop.
flip flop, yeah.
Next flip flop. So that means this is acting as a net gauge.
H.
Net gauge. Okay. So net gauge means initially Q1 is 0 only. During this net gauge, what happens? Q1 becomes 1. Till next
1.
exit, it will be 1 only. Again, it becomes 0. Again,
Then it will
during this negate, it becomes 1. Okay, like this, it will go. Okay. So that means if you consider, so this is 0, 0, 1, 1, 0, 0, 1, 1. Okay. And next, this one is acting as a clock, no? For the next flip flop
yeah, this will be, yeah.
for Q2 for Q2. So initially, let us take this is 3.
It is also negate, yeah.
Sorry, this is also negate. Yeah, I wrote a passage. This is negate. Okay, this is negate. Yeah, this is negate. Negate. So what happens here? So this becomes 1 again.
Till
Next
last.
till last, this becomes 1 0. Okay, this is 0 0 0 0 1 1 1 1. Again this becomes 0 only. See here, Q2 Q1 Q naught, no? So this is LSB of the flip flop and this is MSB of the flip flop. 0 0 0 0 0 0 1 1 0 1 0 2 0113
3.
and 1004, 1015, 1110 1117. Again it will come to 0. With timing diagram also it's proved, no?
Yes, sir.
Suppose if you want to design down counter, what changes I need to make in this?
With postage clock, postage clock.
Yeah, you can give passage clock. Suppose same with negate of clock, what I can do? I need to give Q naught as a clock for the next flip flop, no?
Yeah, next flip flop.
Q1 bar as a clock for the next flip flop. Okay. So the down counter, can you analyze or shall I explain?
I'll try, sir.
Huh? Okay, okay. Down counter. So that means here, uh, so if you write, in conclusion, suppose like if I want to for negate of clock, okay, negate of clock. If you want mod 3 up counter, Q is act as a clock for the
LSB.
clock for the next flip flop, no?
Next flip flop. Yeah.
Next flip flop. And if you want mod 3 down counter,
Two bar.
Q bar act as a clock for the next flip flop. Clock for the next flip flop. Okay. Suppose if it is passage of clock, then if you want to design mod 3 up counter, you need to use Q bar as a clock for the next flip flop. And if you want mod 3 down counter, you need to use Q as a clock for the Q act as a clock for the next flip flop. Is it fine? So this is first one we discussed. Second one you told you will analyze. This is for passage of clock.
Postage of clock.
Anything want to you want me to explain or shall I move forward?
You can move forward. I'll just try it maybe.
Okay, okay, yeah. So next, you want to design, okay, to design a counter with mod less than 2 power n, mod less than 2 power n. Okay, there are some steps are there. Okay, so forcing the counter to so we already discussed some asynchronous inputs. What are the
Hmm.
asynchronous inputs?
Reset and clear.
Yeah, preset and clear. Okay,
Clear.
so here I am using this asynchronous inputs, forcing the forcing the counter forcing the counter to reset. Reset is nothing but clear only. Reset or set to predefined value by activating the asynchronous input. Okay, to predefined defined value by activating the asynchronous inputs. Okay, asynchronous inputs. And next, suppose so that means logic for clear or set active low pin depends on flip flop have high or low. Suppose if you are using output of the flip flop active low means active low clear means you need to use NAND or OR, or if you want to use active NAND and or you can use suppose if you want to use active, this is active low clear. Okay, And if you want to use active high clear, okay, active high clear, you need to use and or, and or, okay. So how we can design, we will discuss with one example. So I want to design mod 6 counter, mod 6 counter, okay. So mod 6 counter means it will count from where to where? 0, 1, 2, 3, 4, 5. After 5 again it will come to
0.
0, 1, okay. It should skip what 6 and 7, 6 and 7, okay. So step 1, what is the step 1? That means you need to find out the number of flip flops. So n is less than or equal to 2 power n,
4 and
6 is less than or equal to 2 power n.
2
How many?
square.
2 square,
Sorry, 2 cube.
2 cube, 2
Hmm.
cube, okay. So n equal to how many? 3 are required, okay. And so first what you need to do means you need to design with the nearest module.
Hmm.
What is the nearest module? You need to design
Hmm.
mod 8 counter, no?
48 counter, yeah.
Okay, you need to design the mod 8 counter, okay. And next step 3, what you need to do means when it reaches 110, okay, it activates reset pin. It activates reset pin, reset pin, okay. Reset pin using the combinational logic, okay. So I'm developing the combinational logic. Let us take the logic QC, QB and QA, okay. QC, QB and QA.
So these steps are for like every counter, like
Every counter,
design.
yeah, every counter, yeah, okay. So three inputs are there. How many possible combinations?
3 inputs, 8
Eight
combinations.
combinations: 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay. So here, here reset logic, this is active low reset means till here this will be in deacceted. That means what? It will be in deactive state. Okay. So when this becomes 110, reset will be activated. Reset will be activated. So
Activated.
from the K map. So what is reset logic? Summation of m of, tell me the minterms.
Uh, 0 to 5.
5, 0 to 5. Yeah, I'll draw the K map. So what are the inputs? QC, QB, and QA. 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 1, 2, 3, next 4, 5, 6, 7. So 1, 2, 3, 4, 4, 5. Okay.
Quad
So this is one quad. This is one quad
and one quad.
and one more quad. Yeah. So
Hmm.
this you can write as QC bar, and this one you can write as
Cube, 1 minute, son. QB bar.
QB.
QC QB,
Yeah.
QB bar.
So reset logic I got QB bar plus QC
Plus
bar.
QC.
So this one I can write as QB QC whole bar.
Hmm.
Which gate I need to use?
NAND gate.
NAND gate. So previously I told no, if it is a active low reset means you need to use the NAND or if it is active high clearer set means you need to use AND or NOR. Okay. So I am designing this. So how many flip flops are required?
3 flip flops.
Three flip flops are required. So I'm using this is flip flop A, flip flop B, flip flop C. Okay. So I'm using JK flip flop. So JK flip flop means this is JAKA, JBKB, JAKA QA, and JBKB QB, JCKC
So
QC.
we can use either T or JK flip flop,
Yeah,
right? Or only
your wish, your wish. That means a T flip flop means only one input will be there, no? So it is given to which one? Toggle mode, no?
toggle mode, yeah.
This is given to toggle mode. Okay, either T flip flop or JK flip
Or
flop.
JK.
This is nothing but first you need to design the mod counter, nearest mod of the counter. So this is negage of clock means Q is acting as a clock for the next flip flop. Okay,
Hmm.
and asynchronous inputs. What are the asynchronous
Please
inputs for each gate?
reset clear.
Preset clear. Yeah, preset clear. Clear is active high. Let us take clear is active high. Preset is active high only. Here preset and clear is active low. Okay, so this is clear. I'm giving signal clear. Okay, and here one more clock. Okay, next QB QB and QC
QC.
connected with the
Reset.
NAND gate. No?
NAND gate.
NAND gate, and this one is given to
Clear.
clear signal. This one I am giving to clear signal. Okay, so that means we will
Clear means it makes zero or re
it will force the output to zero
to
irrespective of
zero.
input and
Okay.
clock. Okay,
Okay.
so
Preset it makes one.
it will make one. Yeah, it will make one. So here from 0 to 5, we will check any value. Tell me from 0 to 5.
2.
2.
Depending.
Okay. 2 means what? 0, 1, 0. No. 0, 1, 0 means this is MSB of the flip flop, and this is LSB of the counter. LSB of the flip flop, and so MSB means this is 0, 1, 0. Okay. So
Hmm.
1 and 0 means what for the NAND gate? 1 and 0 whole
1 and 0 for the whole bar.
0.
0.
This is 1, no?
1.
1. So 1 means what? This is 1 means. So 1 is given to all the clear signals. So
It
that
will
means
be
it will
0.
be deactive state. It will do
Hmm.
normal count only. It will count to
Hmm.
next count. So that means from 2 to 3 it will count. Okay. And we'll check with two values. Those are 6 comma 7.
Hmm.
Suppose which one I need to check?
I think so. 6.
6. Yeah, 6 means now this becomes 1, this becomes 1, and this becomes 0. No?
0.
Okay.
Hmm.
So 1 1 1 1 means what? 1 and 1 whole bar. So this is 1 bar. This is equal to what? 0. No?
0.
0. So 0 means what? So,
Whole
so 0 is come to all the clear circuits irrespective of input and clock. It will force the output to 0.
0.
So that it will count from 0 to 5 only. After 6 it is coming, it will come to the initial state. So it will come.
If 0 comes to clear, it is not get, so it is 1. So it is activated clear.
Yeah, the bubble is there, no? Active.
So if it is 1, it is not activated
Yes,
clear.
it is not
Okay.
activated. Yeah. Okay. So just to draw the timing diagram, and also you try to design mod 6 counter with active high clear. If you are not getting, we'll discuss tomorrow.
Active high clear, it's like no bubble clear, like no bubble thing clear for clear.
You need to develop the logic. So you need to use in place of NAND gate, you need to use AND gate.
Yes, sir.
Okay, you need to use AND gate. Okay. Is it fine? Any doubts or queries?